Hello everyone, welcome back to the good stuff we've been doing. So let's see how we form the product of integral functions. Just as I discussed in the previous videos, we integral function are function like they involve, let's say, p expressions that involve a constant and the unknown but with integral powers. So the sum of this will be regarded as an integral function. And we discussed also that for integral functions in single variable, it is in this form. Let's say a being 8 sub n x to the n plus a sub n minus 1 x to the n minus 1, and then we'll continue plus a sub 2s squared plus a sub 1x plus a sub o. So these are examples we gave in the previous video I did. So if you haven't watched that, you should just check it out. That was an introduction. Here we're going to multiply two integral functions. We'll start with a simple case. Suppose that one of them is x plus a and the other being x minus x plus b. Of course, they are both integral functions, x to the first power, x to the first power, and then b and a and b are the constant term. Here, if we multiply them out here, we notice that here x will combine with x to give us x squared. Of course, then we will still have ab, but then the other thing that will be missing is that x has to combine with b and then a has to combine with x. Those are the only things missing, so we should get something like bx plus ax. But then it is customary when you are working on integral function to express them in terms of ascending powers. So this will be a plus b. So like descending powers, so this is plus ab, either ascending or descending powers. So this form, either x is decreasing, we may write this as ab plus a plus b x plus x squared, but nobody ever does write it this way for this special case here. So here we're going to leave it in this form, and what we observe next is that here we are multiplying out x plus a and x plus b. The end product was that we just have x squared, then we have a plus b and then ab. Now if we change a to negative a, we will have that x minus a multiplying x plus b is same thing as, then here will be x squared plus, then we have negative a plus b x minus ab, and then if we see change b negative as well, this will be x squared, but then we'll be having negative a negative b, then we'll be having plus ab, because negative a minus negative b is plus ab. So the end result would then have to be x squared minus then a plus b. No, sorry, we'll be having x here as well. So we'll be having a plus b. Sorry about this. So we'll be having a plus b x plus ab. So here we'll be having an x here. So I think this is the general form you can expand this expression here. Easily we can expand x plus a multiply x plus b. Now all we have to do is just write x squared down, then we write a plus b addition, then we put an x, then we write ab, and we are going to see that this is a useful formula if we are going to remember. Let's work an example on this. Let's try to expand expressions such as this. Here we have px plus q, and then we'll have rx plus s. So what this will do is that we're going to put it in this form we know. So we'll be having p will come out, then we'll have x plus q over p, and then here r will come out, and then we're having s, not s but an x instead. x plus, then we have x over r. Reason with that, p come here, we have px, then p come here, p cancel p, then we have a q. Likewise for r come here, rx, r come here, r cancel r, have an s. So what we'll be having next is this. We have pr grouped. We'll be having pr. Then we'll be having to multiply x plus p, not p, but s plus q over p. So we'll be having to multiply x plus q all divided by p, and x plus s over r. So like using what we've been doing before, this is pr. Then we'll be having x squared here plus, we will have to sum these guys, p over q plus s over r. They will put x, they'll have to multiply them, p over q times x over r. That is using what we've been doing before. So what we'll do next is to put pr here, and then this will become x squared. This will be plus, here we'll be having pr plus qx all over qr x plus then ps all over qr. If we distribute this out, we have pr x squared plus the pr here, we cancel the pr here to get pr plus qs times x plus then pr cancel pr, we get ps. So since that this, if we expand this expression here, pr plus q times rx plus s, it will be having something like this. So this is equals to pr plus q times rs plus rx and it's even px, not pr, px, sorry. So here, anytime we're going to multiply two algebraic expression, let's say x plus 1 over 3 and x plus 1 over 2, all we have to do is just put x squared, then we'll have to add 1 over 3 plus 1 over 2, then we'll have to put x, then we'll have to multiply 1 over 3 times 1 over 2. So end result would then be equal to x squared plus say 5 over 6x plus 1 over 6. So this is a useful way of multiplying out the terms here, rather than just doing x times all this, x, y, 1 over 3 times all this. So I've discovered a very useful formula in this section here. For this is for the 2 variable case here. In the next video, we'll look at the case of 3 variable case, whereby we'll be having x plus a, x plus b, and then x plus z, s plus c. Let's see if there's a neat formula involving anything like this for the next video. That's what we're going to examine. For this case, we only consider the integral functions, their product for for the case where we have 2 products. So let's go to the part 2 of the video. Thank you for watching, and please subscribe. Have a nice day.